And I begin again. This time with polynomial factorization, factoring trinomials. Trinomials, which are quadratics. So let's do it. B add 7 times B add 1. N take 10 times N take 1. M add 10 times M take 9. How about N add 6 times N take 2? N take 9 times N take 1. B add 8 squared. And here we have M add 6 times M take 4. And X take. What do we have here? Perplexion. 2 and 12. 2 and 12, 4 and 6, 3 and 8. I say cannot be factored. Unfactorizable. How about that? And we check by using the discriminant, which is b squared minus 4ac. Square that, you get 16, and take away 4 times 24, which is 96. 16 take 96 is negative 80, which is not a perfect square, and furthermore, it's not even positive. Anyhow, on with the show. Let's see, 5 and 8. And 9 and 2. And negative 8 and positive 7. And minus 2, minus 3. And b take 2 times b take 4. And n plus 2 times n plus 4. And now they appear to not be monic quadratics or monic trinomials because the leading coefficient is not 1. But that doesn't bother us even a bit because we can just divide everything through by 2. And then we get n squared at 3n, take 54, which is clearly 9 and 6. Beautiful. Divide everything through by 5. And we get n squared at 2n add 4, which is a perfect square. By 2, we get k squared at 11 at 30. And here we go. V squared takes 6v at 8. Okay. V take 4 take 2. Factor out 2. We get p squared at p take 2. P squared at p take 2. Well, that would be p add 2 times p take 1. Factor out 4 and we get v squared take v take 2. So v take 2 add 1. And here, and here, And finally here, factor out 6, we get v squared at 11v at 10. What a delight. I absolutely love that. But I must check. Everything must be checked. Not a single stone unturned. Okay, all good so far. They say not factorable, I say not factorizable. We are different, but that's okay. Oh no! You're kidding me. Did I do that? That'd be n squared at 2n at 4. You're right. You're right. Too eager to factorize that. Do that again. There. And it's all good. That was truly enjoyable. And now a little bit harder. Non-monic, where the leading coefficient is no longer 1. So a little bit slow motion, but it's all right. 3pp. Okay. 5 and 1. There. There. What can we say here? Nope. Oh, I know. How about that? And do. 2 and 14. 4 and 7. Absolutely. Factor out 3. And continue. And huzzah! And factor out 3. And take 2 and add 1. That's good. 5x next. And good. And next. Not sure. Not sure. No. again. There, much better. And here, again, no. There. But what now? No, wrong. Oh, I see. There. No. There. Something like this. Great. Bring the minus sign out. Now. Oh, I know. No, actually, that's not going to work. You do that, and I see where you're coming from. 6a squared plus 25, take 25. But when you distribute the minus, it doesn't work. Slow down. B squared is 625. Take away 24 times 25. Well, that gives us 25. So it is factorizable. But how into what? How into what? And why into what? How about this? Perfect. Oh, I know. Not gonna work, I'm afraid. Oh. That's better. And what? Factor out the 4. Okay. Pardon? There. Doesn't work. Sorry. Okay. Whoops. Oh, I know. There. Hooray. And now to check. Never just accepting the feeling of doing well, but computing well means checking. And that's good. And so is that. And so is that. And hooray! All is okay. Do 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 do. And now for a little bit more. Factoring special cases. Factor them completely. Okay, 4n at 3. Wait, I forgot to say how many. Okay, 22 is coming up. It's 4n at 3 times 4n take 3. 2m at 5 times 2m take 5. 4b take 5 squared. 2x minus 1 squared. 3x plus 1 times 3x minus 1. And n plus 5 times n take 5. And n squared plus 10 times n squared take 10. Beautiful. A squared take 3 times a squared plus 3. Love it. K squared at 6 times k squared take 6. And n squared take 7 times n squared plus 7. But then we pause, because we notice they're not perfect squares until we do this. Oh, this is delightful when it's in this form. And here we go. Could have factored out the 2. Could have factored out the 4, I meant to say. And there we go. And now, how about that? And thus, n squared at 10 and at 25. And thus, really? Yes, really. Hold on. That's not true. I spotted that mistake. Did I make an error somewhere else, though? That's the question. No, it feels okay. Feels okay. One take r times 1 plus r. Oh man, I really simply adore doing these. And look at this, even more beauties. 49 take b squared, so 7 take b times 7 plus b. And factor out the 9. The 9b squared, excuse me. So it becomes 9. Like that. And who's there? We div out by 8. Okay, so but by 8 doesn't work. Yes, it does. Yay. And now to check. Because there is no computing or calculating without checking. Check. It's correct. That's correct. And that's correct. And that is correct. That's correct. And that's all good. I can't believe how quick that ended. I wish it could have gone on longer, but when you enjoy something, it only takes, it ends so soon, you know? So I'm going to take a small break and then resume. Be well. Be well.